On today's Maker Mashup, day 5 of our DIY CoreXY 3D printer build series. So today is day 5 of our build series. Now our printer looks like a printer and there's only one thing that's keeping it from working, and that's the electrical systems. And as you can see here, I've got spread out all over the table all sorts of different connectors and wires. And we're gonna go ahead and put those in the printer today, and I'm gonna cover most of the cabling that you're gonna need to do your build. Now, because this build is a framework and you can customize it to have dual power supplies or any type of motherboard, I'm gonna cover the one that is in the reference build and with a single power supply. So if you're gonna be putting dual power supplies in, you should understand what you're doing before getting into that, and you may need more wires than what is here in front of me now. So because this is a DIY build, you really have a lot of versatility when it comes to how you want to put things together. Now, I chose to use this very heavy-duty signal cable that's in the bill of materials, but you don't have to use this. You can use individual wires, you can wire it up and solder it yourself, and then add these connectors on the back end that hook into the motherboard. So you can really approach it any way that you want, but I chose to use this cable because I like the appearance of it a little bit better than just a wire loom like this that is connected and then just wrapped with some cable coverings. Now, when it comes to attaching it to the carriage itself, there are a couple of options. The option I'm approaching this with is that we're gonna go ahead and solder this because I don't make a lot of changes to the hot end. I have printers that I use for experimental purposes, but for a build where I'm just gonna use the printer, I just solder everything because I'm not going to be changing things out. And if I need to replace a fan, it's not that much work to cut a wire and resolder it. So for me, that's the easier approach. Now, if you're somebody that tinkers a lot with it, there's going to be another cable mount that's going to be coming out here soon, and I'll address that in a separate video. But that cable mount will allow you to use ferrule connectors and just put them in there. So if you want to change out your fans regularly or your hot end, whatever you want to change, that might be better suited for you. But I think the majority of people simply want to put the printer together and then start using the printer for what it is. So we're going to be approaching it from that approach today. Now, since we're talking about the printer, I do want to give a couple of small updates about the printer. Because this is an open source build and it's constantly evolving and improving itself, one of the things that we have gone ahead and done is change the back panel already. And it's not really so much a change as an option. So right now we're using these type of connectors. And if you watched the second video, I believe it was, what we did in this video is we pushed this in. There's no connectors here, so the screws would not fit in because of the extrusion, but we used a little bit of hot glue, attached it, and honestly, that will work just fine. A lot of modern day electronics you buy off the shelf have hot glue inside, so really wasn't worried about its longevity and how it would work on the printer. However, we did run across recently these square ones. Now, the difference between these is that there's little prongs here that will allow you to just simply take this and push it into the 3D part. And once we've pushed this in here, it snaps into place. That keeps it from coming out. So you don't even need hot glue with this. And this model is going to be with the Thingiverse files. It'll basically be a slightly different one that supports this. And I will also put a link for this one as an optional component in the bill of materials. So should you want something that looks like this versus the one that we showed in the video earlier, you could change that up because, once again, it's a DIY build, so you can build it any way that you want. Now, one last thing I do want to talk about before we get into today's video is the heat bed. Now, a lot of people have been having a hard time finding this particular style bed. A lot of people are finding the CR10 style beds with the holes, and they've got a different mounting. So we do have a mount that is coming out, and you'll be able to use that mount for that type of heat bed as well. What we saw was that a lot of people were not able to get the slightly larger bed, but they were able to find the CR10 ones, but of course the design didn't have this. So being a DIY build, again, we were able to modify it quickly to be able to support that. So take a look for that in the coming videos, and we'll also go ahead and put those files when they're available into the main files on Thingiverse. So let's talk about what we're going to be working on today, and that is going to be primarily the wiring. We'll get that all in place today, and then we're going to work on burning the firmware to the main board. And then once we do that, we'll print a calibration cube. After that, we're going to be done with the core part of this series. So everything will basically be ready for you to start using this 3D printer how you want to use it at the end of today's video. Now, as I mentioned before, things like the NeoPixels and some other modifications I'm going to be covering in future videos. But the nice thing is that this 5-part core series now allows you to put the printer together, and then in your leisure, you can go ahead and do some of the extras on the printer without having it part of the whole series overall. So just a different way we try to approach this video for those people that wanted to get up and running with the printer and not have to go through waiting for all of the videos to cover things like NeoPixels and things like that. So with all that said, let's get to work. Day 5 is all about the electronics. We're going to go ahead and make some cables and then wire up the printer, including soldering the carriage wires. Once that's done, we're going to load the firmware onto the main board, and then we'll unit test and tweak our configurations. Once that's all completed, then we'll print a test cube and we'll be ready to go. Since I'm going to be using the signal cable listed in the bill of materials, the first thing I'm going to have to do is strip off some of this insulation so I can get at those wires. I'm just using a razor blade to cut gently into the insulation and casing without actually hitting the wires themselves. Once the outer case is removed, we're going to remove the inside protective layer and expose all the wires. And then the other thing I do as well is pull out all the individual strings and cut all of this off, leaving just the wires in place. Then you're going to want to strip all the wires. Now I'm leaving these a little bit longer because this is the end that I'm going to be using to wire the carriage itself. The other end, where we're going to attach the JST connectors, you're going to want to leave a very, very small amount, and it may take a little bit of trial and error so that way you get all of the JST connectors to attach properly with the right amount of exposed wire. So you can see here I've wired up a couple of the JST connectors already, and I've also gone ahead and wired up some of the ferrule connectors as well. Now you can see here that this wire is stripped much shorter in length, and I'm going to crimp on one of these connectors that work for the JST. They have a very, very tight fit, so you need to make sure that the insulation goes all the way in. Once you've got it on there and you're ready to crimp it, just go ahead and crimp them, and then you're going to go ahead and insert them into the JST connectors once you've got them all crimped. Now what I've done to make this a lot easier is I've gone ahead and created a spreadsheet that shows you the different connections that need to be made and what type of connectors they need to be. And that's included in the bill of materials and also the link of the description. Now that our main wiring loom is complete, we're going to go ahead and add some ferrule connectors to the ends of this wired connector that they provide with the MOSFET. And what this is going to do is it's going to go where the heat bed would normally go, where the heat bed wires are, and then it will go ahead and send that as a signal over to the MOSFET, which will control our heat bed. Now we're going to go ahead and use some of these spade connectors to create ourselves a very short piece of wiring, and we've got a black and red, so our positive and negative, that's going to be going from our power supply over to the MOSFET. Always make sure that you get a good crimp, and then give the wires just a little tug to make sure they're in there securely. We don't want any of these falling out or these connections being loose. Now I'm going to go ahead and wire up the incoming power lines. Now I've used my regional wiring, and I suggest you use the regional wiring for your country. Now mine happens to be yellow, red, and blue, and those are the same ones that happen to come with the module. However, the wires as part of that inlet module are a bit too short, so I created some new ones here, and then we'll go ahead and wire these up. So you can see the connectors that came with the inlet module are clearly way too short. So what I'm going to do is just use my replacements instead. And I'm just going to unhook these, and then each one of them I'm going to wire into the power supply. Because each country does have different power requirements, please make sure you take the time to understand how you need to wire your power supply and whether or not you need 110 or 220 as the input voltage. That's one sure way to end up with a dead power supply before you even get the printer running, is having this wired in correctly. So take a few extra minutes, research it, and make sure that everything is wired properly. One last note, it's much easier while you're putting the printer together to do your wire management. So go ahead, grab those zip ties, and make sure everything's nice and neat as you're putting it into the printer. Now we're going to go ahead and wire up the signal cable that will trigger our MOSFET. As I mentioned before, we're just going to insert these little ferrule connectors, and it's going to insert them right where the heat bed would normally go onto the main board. Now it's going to go ahead then and we'll stretch it over the main board, and we'll hook it up to the MOSFET where you see J2. As you can see, I probably should have put the MOSFET just a little bit closer to the main board, just barely enough wire to reach, and it does actually work, and I'll probably end up switching this wire out at a later date. Now we're going to go ahead and hook up the positive and negative leads to the MOSFET itself. Now these are coming from the power supply, so these are going to be the shorter ones that we built earlier. And then we're just going to go ahead and hook them up to the positive and negative on the MOSFET itself. Now we're going to go ahead and hook up the heat bed wires. Now this is fed through the USB panel, and it is the rightmost hole that you're going to want to feed this and the thermistor through. And then we're just going to go ahead and hook these up to the MOSFET, and the heat bed's all done. The last thing you'll need to do is take the thermistor wire from the heat bed and plug that into the main board. Next, we're going to go ahead and hook up the main power leads. Now we're just going to insert these two ferrule connectors into the main board here, and this is where the positive and negative feed into the main board. And then after that, we're going to go ahead and connect these up to the power supply. Now we're going to go ahead and remove the front display panel, and then what we're going to do is use the ribbon cables that came with the display, and we're going to plug those in. And there's an EXP1 and an EXP2, so you need to make sure that you match the ribbon cable with the proper one on the main board. So after inserting them here, then you'll just match it up and install it into the main board, and then we'll reattach the display. Now we're going to go ahead and feed our wiring loom through the back of the printer, and then after that we're going to hook up all the different connectors. We're going to start by plugging in the extruder motor, and then after that we're going to insert the hot end with the ferrule connectors into the main board. And then we'll plug in the thermistor for the hot end. Now we're going to go ahead and insert the always on fan, which is the one that's on the cool side of the hot end. And then after that, we're going to plug in the blower motor for the part cooling fan. The last thing we need to do is hook up the Z end stop. Once we've connected this, all of our mainboard connections are in place. Now we just need to hook up the mechanical end stop. We don't need to tighten this down very much until we go ahead and start leveling our bed. So we're just going to go ahead, put it into place, and tighten the screws tight enough to hold it on. Now I've turned the printer around, and what I'm going to do here is just attach the signal cable with a zip tie to the cable mount in the rear of the printer. Now this isn't going to be its final resting place, but the zip tie will hold it so that way I can go ahead and solder up these leads. Now I'm going to go ahead and trim the stepper wires, and then we're going to solder them up. Now, as I mentioned earlier, I have put together a worksheet that you can follow, which will show you the different colors and how to hook them up to the stepper and how to hook them up to the JST connectors, and that is included in the description. Don't forget to add some shrink tubing before you start soldering. Now, to help the soldering process, you can get one of these helping hands. They're available on Thingiverse, and I found it super helpful for doing the soldering on the back of the printer. Once we get all of the stepper wires soldered, then you're going to want to use a heat gun and shrink all of the shrink tubing. Now you're going to want to use the same process for the rest of the wiring. Once it's all complete, then we'll work on attaching the loom and get that inserted into the carriage. The cable plate on the carriage is designed to hold this little bit of excess wire that we have from our soldering. What you'll do is create a small loop, and that will go ahead and put all the wires together, and it will also make this area a bit thicker. Then you're going to want to use some cable wrap, and you just start at the bottom and wrap the cable wrap only as far enough to wrap your wires and make it a little bit of the way down the signal wire itself. This part takes a little bit of patience, but what you need to do is take that wrapped cable and you're going to put it into the cable plate, and then once you have it resting in there, then you're going to use a zip tie to hold it all into place. Now we're going to go ahead and insert the Bowden tube into the dual drive extruder. Now remember, all this is being used for is to guide the filament. You don't really have a Bowden system here. It is set up as a direct drive. Once you have that Bowden tube inserted, you're going to want to wrap the cable wrap around the Bowden tube a few times. This is going to add some additional support to the cables going to the back of the printer. Now we're going to go ahead and attach the Bowden tube and the signal cable to the rear cable guide. You can attach this any way you like, but the way that I do it is one side is for the signal cable, and the zip tie will hold it into place pretty well, and then the other side I use for the Bowden. Now with the signal cable, you're going to want to make sure that this is pretty tight, but for the Bowden tube, you're going to need to make sure that it's loose. You just want it to hold the Bowden in place, but you don't want it to be so tight that it causes restriction of the filament going through the Bowden tube. Okay, so at this point, your printer is really assembled, and the only thing that we're going to be doing in the next steps is really wrapping up the firmware, doing some unit tests, and making sure that we're ready to go with a test cube. Now, before we start all that, I want to say at this point, double check all of your wiring. Make sure that you go through it step by step and make sure it's correct before you power everything up. So our next steps in the video here are going to be to load the firmware, then we're going to attach the build plate on here, and then we're also going to do the acrylic and then run our test cube. But the real key at this point is make sure all of your wiring is correct before you turn it on. Once you turn it on, there's no turning back, and if something's wired incorrectly, you could blow out your motherboard or possibly worse. So the next step here is really compiling the firmware, and then we're going to run our unit tests. Now, I'm not going to cover step-by-step how to compile firmware. There's so many videos out there, and this video is already long enough. I just want to cover the few things in the configuration file that you should be changing, and then you'll need to compile the firmware, get it on the printer, and run the unit tests. So let's talk about the configurations, and then let's get this printer wrapped up so we can print ourselves a test cube. Okay, so we have the configuration.h file of Marlin open, and once you get Marlin downloaded, you'll see that the X301 configuration is pretty much the same as the standard configuration for Marlin. There's just a few changes, and we've set some of the settings up for you already. So the first thing we're going to do is just page down through here, and you're going to want to go ahead and assign yourself a unique machine ID. Now this isn't required, but I've always thought thought of this as a way to make sure that my printer version's always unique for things like Octoprint and other software that communicates and reads the UUID out of your 3D printer. You could just go to this website here and generate one. It doesn't cost anything, and then you're going to want to paste it in here. The next thing you're going to want to do is to scroll down through here, and you're going to want to check to make sure that all of the settings are correct for your particular printer. Now, there's a lot of different settings in this file, and I really recommend walking through and reading each one to understand what they're for. Now, the first thing that you may run into is going to be your temperature sensor. Now, 5 is generally the default for many temperature probes that are out there for both the heat bed and for the nozzle itself. But you need to verify what one that you purchased and what the setting is. As you can see here, there's a lot of different settings for the thermistor itself, and it's important that you select the right one. Otherwise, your 3D printer won't know the proper temperature. So the next thing we want to talk about is the end stop inverting, because this is one of those things that throw people off, usually when they're trying to compile Marlin for the first time. Now, we've got this set for the inverting equals true, and this is what works for 90% of the end stops that are out there. And since we have a mechanical end stop, this value is going to apply. Now, it could be false or it could be true. If you find that your printer is not homing correctly and it's not stopping when it gets to the Z end stop, then you might try inverting this value and that might correct it. Or if the printer starts to move and try to home but then immediately stops, it's definitely this value on the end stop inverting. Now, another important area to look at is the stepper drivers. Now, this is configured for the 2209, which is required for the X and Y axis for the sensorless homing. Now, I've purchased 2225s for my particular printer, and they're identical to the TMC 2208. So Marlin doesn't have a 2225 setting, so if you do have those, it is just going to be the TMC 2208s. But you're going to want to set this up for your X, Y, Z, and extruder. And if you have multiple extruders, it's important that you set whatever the driver type is to match the type of driver that you put on the motherboard. Another problem that trip a lot of people up is the stepper direction. Now, I've got all of mine set for false. If you find that your printer is moving the wrong direction, so you're homing to the max or it's going to the max, instead of going down to the lower left-hand corner of your build plate, the invert the stepper direction will fix that. Now, setting it to true or false changes the way that it operates. So if it's moving the wrong way, change one of these values and you should be in business. And another item here is to look at the stepper direction for the extruder. Now, if you're using the one from the bill of materials, you probably won't have a problem with this, but if you find it's not feeding filament, this could be set for the wrong direction. The last thing I want to talk about today is the SD card connection. Now you can see here the default and the way that it is set up, it's currently using the onboard SD card. Now there's a couple of things you need to keep in mind for this. If you're going to leave it on the SD card that is the onboard one, it's important that what you do is release the media from the main display screen once you go ahead and want to load new firmware. So the first time you load firmware, it'll work fine, but as soon as this setting becomes enabled for the onboard, you'll need to go in and release the media on the display screen in order for you to burn more copies of the firmware or update your firmware on your board. Now that you've got the firmware loaded, it's time to finish up this printer. We're going to start by spraying some lithium grease on a shop towel, and I find this is the easiest way to apply lithium grease to the lead screws. Now, once I've got it on the paper towel, I just fold it up to create a small area. And then what I'm going to go ahead and do is to go ahead and rub the lithium grease onto the screws a little bit in various places. And then what I'll do is I'll use the printer to run that thread up and down. So I'll move the bed up and down the printer. And that keeps the lithium grease on the lead screws specifically. And it doesn't create a mess all over the rest of the printer. And I found this pretty successful over the years. Once you have the lithium grease on there, then you're going to want to move your axis up and down a little bit just to work the grease into all of the lead screw. Now I'm going to go ahead and apply my build surface. Now for this, we're just going to want to make sure that we spray down everything with some 90% or greater isopropyl alcohol. And then once you've got this all cleaned up, then what we're going to do is start from the edge closest to us, and we're going to put that magnetic sheet on. And I've already lined it up so I know where it needs to go. But once you stick this in place, it's nearly impossible to remove it. So make sure that you line everything up before you attach it to your bed. Now you're going to go ahead and insert all of the stops for the acrylic sheet into the printer. Now this just uses an M5 screw and T-nut, and it holds these little pieces in place that the acrylic's going to rest on. Now you can print as many of these as you'd like. I usually use about 2 per side, and that holds the acrylic perfectly. Now, if you have everything lined up, the acrylic should slide right into place and rest on all of the stops, and the gap should line up roughly with the 2040 extrusion on the sides. Now we're going to go ahead and feed some filament in here, and this process is pretty easy. Just go ahead and drop the spool right there on the spool mount, and then you're going to go ahead and feed the filament after cutting a nice sharp point all the way up through the Bowden tube, and that's going to reach the top of the dual drive extruder. Now once you get it up to the dual drive extruder, then what we're going to do is go to our control panel on the front, and then we're going to go ahead and load filament. Now it takes anywhere from 25 to 100 millimeters worth of filament to grab the filament and push it down through the nozzle. Now that we have the filament loaded, it's time to level the bed. So we're going to go into the motion, and then we're just going to level the corners on this printer, and that should get us close enough where we're ready to go ahead and print a test cube. One quick tip on leveling the bed with this large bed: you can go ahead and use a screwdriver here and actually just use the bit driver to tighten up everything or loosen it as needed when bed leveling. Now it's time to spin up a calibration cube. I print a standard 20 by 20 millimeter calibration cube, and then we're going to go ahead and measure this and see how close we are. The first one looks a little rough, but not too bad. We're going to go ahead and make some changes, and then we'll go ahead and print another one. The second cube is looking very nice. Nice smooth finish, and I'm not seeing ringing in the print as I would expect with a CoreXY build. And I love that build plate. That texture bed is one of my favorites. Looking at the calipers, it looks like we got a little bit more tuning to do, but I'm going to go ahead and call this a successful test cube. So after a little more than 5 weeks, here we have it, the LayerFused X301 printer, and we've got it pretty much assembled here. We're going to have some videos coming forward in the next few weeks. We're going to go ahead and do the NeoPixels video. I also want to kind of do a pimp your printer where we can kind of talk about how to make certain enhancements to put channel covers on there, really give it a little bit more of a nice look. It looks very clean right now. I love the acrylic in this printer. It's one of my favorite parts, and that electronics enclosure is really, really big. But want to get the LED lights on here, and really just, we're going to be working on a few more different videos coming out. So make sure, if you're not a subscriber, to subscribe now and click that bell so you don't miss any of the upcoming videos on the printer. I also want to take a moment first to thank Nick, who I have worked over the last year to develop this printer. Nick and I have been working very tirelessly over this printer, continuing its development and putting it together so that we could share it with you. And I also want to thank all of my Patreon members. Thank you for your support of the channel, and thank you for your help, especially the insiders who Buddy, Jay Long, Carson. Thank you guys for being insiders, for helping out with the printer and in the sense of all of the QA and making sure that the videos are all matching up to the bill of materials. Your amount of help has really been great, and I hope that you're very happy with your X301 printers that you've been building. Now, if you'd like to help support the channel, please consider checking out our Patreon page, where our patrons get exclusive access and early access to content that we don't have on the channel itself, but they get early access to a lot of the 3D printed parts and are able to really be a part of our community online. And we do have a public community online as well. That is in the Discord, and there's also a Reddit as well. So there's a lot of how-to guides that I've been putting out there. So if you're interested in how to print the parts, or you're interested in the tuning, which we'll be working on here soon, all of those will be in how-to guides, so you can see them online and read them at your leisure. So I hope that everyone has really enjoyed this series as much as I have. I've really enjoyed this series, putting this printer together, sharing it with you, working with Nick. It's been a long year of a lot of work, but it's been a lot of fun. So thank you for watching these videos, and thank you for being a subscriber to the channel. And with all that said, I'm gonna say thanks for watching, and we'll see you guys next time.